So one of the major things that we can appreciate Albert Einstein for is helping us understand gravity in a way that defies our common intuitions. And what I mean by that is the average person today understands gravity in a Newtonian sense, through the lens of classical physics, as proposed by Isaac Newton. And this comes from the theory of universal gravitation. You see how the average person just thinks of gravity as the idea of falling objects. You throw a heavy object up in the sky, then it comes falling down. Let me give you an illustration perhaps as a way to help you understand how Albert Einstein explained what gravity is. Before Albert Einstein's theory of general relativity, people primarily understood gravity through the lens of classical physics, particularly Isaac Newton's theory of gravity. Newton's theory, known as the law of universal gravitation, was formulated in the late 17th century and was the prevailing explanation for gravity for over 2 centuries. According to Newton's theory, gravity is a force that exists between any two objects with mass. It states that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In simpler terms, the larger the masses of the objects and the closer they are to each other, the stronger the gravitational force between them. Newton's theory provided an accurate and effective way to predict the motion of celestial bodies, such as planets and moons, and it successfully explained many phenomena related to gravity on Earth and in space. For example, it explained why objects fall to the ground when dropped, why the moon orbits around the Earth, and why planets orbit around the sun. However, Newton's theory had some limitations, and one notable issue was that it couldn't fully explain the observed bending of light around massive objects. This phenomenon, known as gravitational lensing, was later explained by Einstein's theory of general relativity. Albert Einstein's theory of general relativity provided a groundbreaking and revolutionary explanation of gravity, different from the traditional understanding provided by Newton's theory. Einstein's theory, published in 1915, introduced a way of looking at gravity involving the geometry of spacetime. In general relativity, Einstein proposed that gravity is not a mysterious force acting at a distance, as Newton described it. Instead, he suggested that massive objects like stars and planets actually curve the fabric of space and time around them. This curvature is what we experience as gravity, causing objects to follow specific paths as they move through space. Let's use an illustration to unpack the thought. Imagine the universe as a giant fabric, like a cosmic blanket stretching across space. When objects with mass, like stars and planets, sit on this fabric, they create dents, just like when you press down on a mattress. Now imagine a little marble rolling on this fabric. It doesn't move in a straight line. Instead, it follows the curved path created by the dents made by the massive objects. This curved path is what we experience as gravity, pulling objects towards each other. The curvature of the cosmic fabric reintroduces the concept of gravity as the bending of space and time itself, a concept that vastly differs from classical Newtonian physics, where gravity was seen merely as a mysterious pulling force. Instead, the cosmic blanket offers a captivating perspective of gravity. Objects are not merely pulled towards each other, but they naturally follow the curves and dents created by the presence of mass. On this cosmic fabric, planets, moons, and other celestial objects dance to the tune of the curving of space and time. Picture planets orbiting around the stars as graceful dancers elegantly following the curves of the cosmic fabric. One of the astonishing consequences of general relativity's cosmic fabric is gravitational lensing. Just as a lens bends and focuses light, massive objects warp the fabric of spacetime, causing light from distant stars to bend as it travels near them. This phenomenon allows astronomers to observe distant galaxies and celestial events that would otherwise be hidden from our view. The cosmic blanket of general relativity has led us on an extraordinary journey of discovery, unraveling the secrets of gravity and illuminating the nature of our universe. Einstein's theory of general relativity continues to stand as a testament to human intellect and curiosity, forever transforming our understanding of the cosmos and our place in it. The idea of this cosmic fabric remains an ever-present reminder of the interconnectedness of space, time, and gravity, inviting us to ponder the countless wonders that lie beyond, and this is not even the end of the story.